Uh, in paper second, we are going to learn the wave optics. In that, today's article it is interference of light. Already we have learned the principle of superposition of waves. What is principle of superposition of waves? Principle of superposition of waves. It can be stated like this: when two or more waves traveling through the medium arrives at a point simultaneously, then they represent their own displacement independent of the other. The resultant displacement is given by the vector sum of the displacements of all the waves. So, this is the principle of superposition of waves. It states that when two or more waves traveling through the medium arrives at a point simultaneously, then they represent their own displacement independent of the other. The resultant displacement is given by vector sum of the displacements of all the waves. It means that if two or more light waves are traveling through the medium, then if they are arriving at a point simultaneously, then they represent their own displacement independent of the other, and their resultant displacement is given by the vector sum of the displacements of all the waves. It means what? There will be an addition or subtraction of the displacement vectors of the waves, and that will be the resultant wave. Next, here we will consider an example of interference. Mind what? With this superposition waves, the interference phenomenon takes place. What is interference? That we are going to learn. Our main interest point, it is interference, and for this purpose we are going to consider the two waves. This is suppose first transverse wave. This is called as a crest. This is called as a trough. This, and it represent displacement y1 from this zero position. y1 on along positive y-axis and y1 along negative y-axis. Next, this is another way. Suppose the displacement of this is y2. This is crest. This is the trough. And this wave also moving in this direction through the same medium. What happens? They are going to superimpose with each other. There are two methods for superimposition. First method, it is like this. Suppose this is one wave. Now this is another wave which is going to superimpose. I am going to show it by dotted lines. Now here the first wave, it has the displacement y1. Here second wave has a displacement y2, and therefore the resultant displacement y will be y1 plus y2. It will be y1 plus y2. Like this. This is the resultant displacement y. Now, when the displacements of the two waves, they are added, then we get resultant displacement. How we got this resultant displacement? That is, when the crest of one wave is going to coincide with the crest of another wave, trough of one wave is going to coincide the trough of another wave, and therefore this superposition of two waves, it is y equal to y1 plus y2. The resultant displacement, it is vector sum of, if I show it like this, vector sum of the displacement of the two waves. Next, same way here, suppose this is one wave. And this is another wave. This I will show it by dotted lines. Right. Now in this case, what is going to happen? There will be a vector sum. Vector sum like this, y equal to vector y1 plus minus vector y2. If y1 is equal to y2, or magnitude of vector y1 is equal to magnitude of vector y2, then this y will be equal to 0. It means the resultant displacement will be equal to 0. Here, the displacement of this wave, it is going to cancel with the displacement of this another wave. And therefore, here, this combination or this phenomenon, it is called as interference. This one and this one. How this interference is going to take place? See here. Here, the amplitudes of the two waves, they are going to add, and hence we get maximum of a wave. Or when two intensities are going to add, then we get maximum intensity of light. When two amplitudes are going to add, we get maximum amplitude. It means that here, due to the superposition, the maximum of the maximum of two waves it is going to form. Here, this is crest and this is trough. They are going to coincide. This is crest, this is trough. They are going to coincide. When they are going to coincide, the resultant displacement is equal to 0, and therefore there is a formation of minimum of light, or minimum intensity of light, or minimum displacement of light. And this phenomenon, formation of maximum or minimum, intensity of light due to superposition of two or more waves, it is called as a interference. Again, I will repeat, the formation of maximum or minimum due to maximum intensity of light due to superposition of two or more waves, it is called as interference of light. Now, this is also called as enhancement. It is also called as cancellation. It is enhancement or cancellation of light waves or intensity of light due to superposition of two or more light waves, and therefore it is also called as an interference of light. Next. Here, the intensity it is becoming maximum. Here intensity it is going to minimum. The minimum intensity of light, that is again recovered in the form of maximum, or cancellation it is recovered in the form of enhancement, and therefore there is a redistribution of light energy. And this phenomenon of redistribution of light energy or intensity of light due to superposition of two or more light waves, it is called as interference. And therefore we define interference like this. The redistribution of light energy due to superposition of two or more light waves is called interference. Of light. There are two types of interference. First is constructive and second is destructive. This is the example of constructive interference. When crest of one wave is going to coincide the crest of another wave, trough of one wave is going to coincide the trough of another wave, then this interference it is called as a constructive interference. The condition for phase difference, phase that is far, it is 0, 2 pi, 4 pi, 6 pi and so on. This is equal to twice n into pi, means even integral of pi. or we can say that if the phase difference is even integral multiple of pi, then we can say that that is a constructive interference. Second, destructive interference, or second condition we will consider, that is a path difference. The path difference, it is equal to 0, lambda, 2 lambda, 3 lambda, and so on, that is equal to n lambda, where n equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. What does it mean? If the path difference is integral multiple of wavelength, where lambda is the wavelength, then the interference is constructive interference. Interference is constructive interference. Now let us see what is the destructive interference. Second is destructive interference. See here, the crest of one wave is going to coincide the trough of another wave, and therefore there is a cancellation of light, or there is a formation of minimum intensity of light. This is called as a destructive interference. For in terms of phase difference, if the phase difference is of pi, 3 pi, 5 pi, and so on, that is n minus half into pi. This n minus half that indicates the odd integer, or it is also equal to twice n minus 1 into pi, odd integral multiple of pi. Then it is the destructive interference. If the phase difference is odd integral multiple of pi, then the interference is destructive interference. Next, path difference. In terms of path difference, we write it is lambda by 2, 3 lambda by 2, 0 lambda, 5 lambda by 2, 7 lambda by 2, or that is equal to twice n minus 1 into lambda by 2. Twice n minus 1 into lambda by 2. So here again we can say that if the path difference is odd integral multiple of half of the wavelength, then it is called as a destructive interference.